Now presenting on the S4 sponsor stage is Mocana. Please welcome CTO Dean Weber to the S4 sponsor stage.
Well, thank you, and thank you for coming. Hopefully you're having a good show. My name is Dean Weber. I'm the Chief Technology Officer for Mocana, and we'll tell you a little bit about what we think the industry is doing or not doing and where we're headed, and maybe even where we should head. There's no try, there's only do. I'm not Yoda, I'm not green, but it is what it is. So, lifecycle management in terms of platform is everything revolving around the platform. It's the element security of the device, it's the network security of the transport, it's the back-end services module associated with the transactions and the physical life cycle of things like certificates, things like the update process. All of these things that make up a security life cycle in an industrial environment is what we're talking about. Needless to say, I don't have to tell you the threat is evolving. If you haven't kept up with times, there's a lot more out there today that hasn't been reported on yet beyond what we've already talked about or what you already know about. It seems like there's some level of vulnerability being opened almost every day. You can read the numbers. I don't need to read them to you. But it's a big problem, right? And if we don't start solving the problem, we're gonna have some issues. So when we think about how the event was opened this morning with Dale, what if? Well, what if we change the security paradigm to protect as opposed to detect and respond? And that's what we're proposing the industry look at trying to do, because the detect and respond model has traditionally proven less than optimal. You have to look no further than over the transom at the IT folks to say whatever the new bolt-on of the day is, whether that's a heuristic-based or human-based analytics, all the new signature matching and behavioral matching technologies that are out there in the IT world. It seems like we're just continuing to try to solve for the threat rather than taking a step back and saying, let's build a secure model from the ground up. Let's build it in such a way that it meets our requirements in terms of trustworthiness, in terms of manageability, in terms of lifecycle management. Those are the things that we're talking about. Unless we do that, the cracks between the technologies are going to continue to be exploited. So if you have secure transport, but it's not tied to the platform security, or you have a root of trust in the platform, but you have no means to convey that trust to an external consumer, these are the kinds of things that we're not going to get past unless we start solving for the prevent problem as opposed to the detect and respond. At the end of the day, it's all about technology and process. The technology exists, right? It just has to be put together in an appropriate format. We have the mechanisms necessary to solve for these kinds of problems today. Hackers are bypassing the controls that we're presenting today, primarily around the ideas of those spaces between the various contribution elements. So again, if you think about the IT world, there are spaces between the OS security mechanisms and the antivirus security mechanisms that are exploited almost every day. Code-based vulnerabilities in the 0 days, language-based vulnerabilities, hardware-based vulnerabilities, right? Meltdown, Spectre, and several more to come. But these are the kinds of things that people are getting past, and they're using our own technologies against us, right? In the IT world, we've gone to 2- and 3-factor authentications, and we're still getting hurt. In the OT world, we don't really have the conversation about a multi-factor authentication because we don't even have a good concept of a single-factor authentication yet. Username and password or embedded passwords is not an appropriate way to address security. So the idea that we have all these insecure or unsecured processes associated with our distributed industrial environments means that they're going to continue to get in. It's just that simple. All right, so add in the concept of supply chain, and what supply chain is ultimately going to end up being. If you're following, for example, the United States government is now writing into law the fact that you have to be able to demonstrate upstream and downstream liability. I just got an email last week from our CFO with a new partner agreement with VMware, who's a customer of ours, to say, should I sign this? Because it's a GDPR downstream liability document. And it is holding my company to task for GDPR. And they're going to expect me or us to go and hold our vendors in the same models, right? And that's all just about PII, because at the end of the day, that's what GDPR really is. It's release of public information about individuals or processes. So I guess the point that I'm making is that supply chain is going to continue to get more focus. We now have NIST guidance in 800-161 and the use of it in 800-171 in terms of how does one construct a supply chain. And again, we have the opportunity to tie all these things together, right? We have the ability to sign code and to sign discrete elements. We have the ability to hash those elements and validate those. We have the ability to revalidate them upon usage. But do we do that today? No, we don't. Why? Because it's hard. It's really, really hard to manage all of those lifecycle functions from your suppliers, your platforms, and ultimately your customers' security systems using your security mechanisms. It's hard. So the point being is that supply side has all kinds of inference here, from how do you get and measure secure contributions? How do you manage those? How do you know that the signing keys from your vendors are good? Not easy to do, because we don't have the mechanisms to automate that process. Basically, you have to contribute their key back to them for validation, or take it at face value that the key isn't compromised. Onboarding devices, right? One of the weakest side components of how do I get the device from where it is in manufacturing to in use in a customer environment. Linking the supply chain elements into the devices and the devices into the subsystems and the subsystems into the systems is what we're trying to get accomplished here. So again, these are all components of a secure supply chain, ranging from how did I get that, TPM from Infineon? How do I know the TPM is good? How did it get installed into my reference system? How did I test it? How do I create that in a repeatable process so all of the manufactured systems can go out with some level of validation of the trust anchor? These are all things that have to be orchestrated, and they're non-trivial. And then last but not least, one of my personal favorites is updates. If there's anybody in here from automotive, you'll know that Uptane's trying to do something with automotive standards. But at the end of the day, the update process as we know it is vulnerable. Unless you're going to great lengths to protect not only the supply side, meaning who's contributing those updates. Again, if Infineon's trying to patch their TPM and you're using their TPM, how do you validate that the update for the TPM came from Infineon? How do you know it's good? How do you know you're using it in a good fashion? And how do you know that you're distributing it to your customers in an acceptable format? These are non-trivial problems. So again, putting all of this together in lifecycle management is what we're trying to accomplish. Well, that's what I said, automating the security lifecycle. So the idea behind all of this is, how do you manage keys, right? I think we're at a point today where we recognize that username and password is not appropriate. As alternatives, we either have proprietary mechanisms or we have standards-based. And either one will do the job. Mocana specifically is about standards-based. So we're talking about standards-based authentication mechanisms. X509, PKI, certificate authorities, HSMs, things that can generate and utilize strong digital identity as a means to identify, as a means to onboard, as a means to validate, and ultimately as a means to decommission a device in the field without having to physically send a body to the field to go do those efforts. All right, so the whole concept of provisioning, right? I mean, I can't tell you the number of customers that I've been in front of in the last couple of years talking about. So, we love the idea of certificates, but it's just too hard. We've got tens of thousands or hundreds of thousands or in some cases millions of devices deployed in the field. How do I do certificate provisioning on them? It doesn't come from the CA. CA is not capable of doing that. So the point here being is that we have mechanisms and orchestration models by which we can create the life cycles associated with not only getting the certificates onto the device, validating their usage, reporting on their function, updating them as necessary. I mean, again, not to pick on the United States government, but if you think about, it's probably been 12 years now since NIST said stop using SHA-1. Blanket statement, it's broke, don't use it. Who is the single largest offender of using SHA-1 today? The United States government. Why is that? Because they can't get to the certificates. In many cases, the certificate authorities that created those elements don't exist any longer. So how do you solve for those problems? You've got to get into some type of life cycle management. And that's what we're espousing here, right? That's what we're saying is the right approach. Take and build orchestration into all of these functions. Automate. Again, what if we were able to automate this process? What if we were able to do security lifecycle management on industrial devices from the sensor/field device through the gateways, through the network, back into the DCS, ICS SCADA world, and beyond? Wouldn't it be nice if we could do that? Okay. The whole concept of onboarding has been something that's been in discussion for several years. Whether that's something that you want to just identify the device and say, yep, that's mine, or whether you want to share ownership. Again, if you get into 800-171, it's about how do you apply ownership? How do you transfer ownership from Infineon to you, the manufacturer, to your customer? How does that transference happen? And if you don't have a process associated with that, trying to do that kind of work manually is extremely time consuming. So everybody from Intel to Secure RF have tried to solve for this problem of how do we get an identity on the device, how do we use that identity for security function on the device throughout its entire life cycle. If you think about how Intel's trying to do it with EPID and SDO, that's a zero-touch provisioning mechanism, right? The device comes on, it calls home to an Intel reservation server. Reservation server says, yep, that's my privacy key. And Intel says, good, it's an Intel device. Next. That doesn't help you with the security policy of what do you do with it from there. How do we make that function part of the overall security platform? We've got to take that onboarding to include the Intel privacy key, and we have to provision additional components to that over the life cycle of the device, both initially and throughout its lifetime. So automating those key functions and automating those provisioning functions and automating those update functions using standards-based approaches is what's going to get you through certification to IEC 62443 or NIST 853R4, soon to be R5, or the security framework, right? The NIST security framework that is now being adopted and adapted to ICS. All of these things are coming, right? Because we recognize that if you had to put IT and OT on an equal scale, the reason that OT measures risk differently is because it's more important. Why is it more important? Because IT decisions don't normally impact human life. They may impact reputation, they may have a financial obligation associated with it, they may even put you out of business, but they're not going to kill you. When we talk about industrial systems, we're talking about the potential for making life and death decisions. How can you make a life and death decision if you don't know that the data that you're using to make the decision is any good or not? That's what it boils down to. We've got to be able to have a mechanism that says, yep, the data is secured because it's a secure platform, it's a secure OS, it's a secure application, it's a secure transport, it's a secure back-end system collecting the data, it's a secure artificial intelligence platform behind that that's utilizing the data. Those are the kind of things that we want to think about when we talk about security systems and lifecycle management. The entire lifecycle, not the device lifecycle, not the OS lifecycle, not the certificate lifecycle, the entire platform. And again, the idea there is that there are all kinds of mechanisms out there to generate keys. Keys aren't the problem. Usage of the keys are the problem. Management of the keys are the problem. So automating and managing those functions in a useful fashion that could be tied into everything, so from your device management platform solution sets to your OT network functions to a back-end security information and event management system out to a third-party set of analytics, SAP, whatever. How are we going to do all that if we don't know that the data that we generated is any good? I was listening to the GE guys this morning talking about exactly that, right? It's all about how do I get the data as generated in a trustworthy fashion into a trustworthy decision process. That's what they're pushing. That's what we're trying to accomplish here. Okay. I think we've talked about provisioning enough. Remote certificate management, like I said with the SHA-1 example, is another big area of concern, where how do I modify that certificate over time? How do I add attributes and artifacts to that certificate as necessary? We've got a use case where a certain customer of ours is taking a platform, and it's a classified platform, and they're shipping it overseas, and they're very, very concerned about in transit, because with physical access, pretty much all bets are off. So if somebody can gain access to that platform while it's in transit, all bets are off as far as the relative cybersecurity of that platform. So what they want to do is they want to be able to enroll that device when it reaches its destination and then put the IP on it through an update process. Those kind of use cases are possible today. We have customers using them today. And this isn't a sales pitch. I'm just talking about, in general, these types of control solutions are available from us and others. Code signing. There is another one. Everybody knows what code signing is, right? Anybody not know what code signing is? All right. So code signing, that's going to be some specialized certificate used to say, here's the code that I wrote. I'm going to sign it, I'm going to hash it, and I'm going to associate those two values so that they can be re-represented at a later date or time. That's what code signing is all about. If we want to do that, great. But how do you manage that? Particularly when you're talking about managed multiple subscriptions of software, multiple OS components, multiple application components, multiple hardware and configuration components. It becomes very, very complex if you don't have an orchestration model. All right. Secure elements and roots of trust. I don't know what more I can tell you about here. The use of a secure element means that someplace the trust model has to start, right? So the certificate itself, or the PKI itself, or whatever the unique identifier is by itself, is not guaranteed unique. How do we guarantee that uniqueness? And the answer is you have to have a secure element, and whether that's TE Trust Zone or a TPM or one of the specialty hardware modules that are out there now, could even be an HSM if you're going to transport all that stuff over the network. But the idea is that you have to have something to base the security upon. So now I've got code signing, I've got all these marvelous certificate functions going on out there, and guess what? At the end of the day, I don't have secure key storage. I'm back to username and password. Unencrypted password in the file system. So we've got to start tying trust to something that is derivative on the platform. Or we have to utilize third-party services of something like an HSM. And if we can do that, now all of a sudden it becomes that much stronger. And it doesn't have to be a TPM, right? It can be any secure element. It could be a SIM. It could be a MIM. We've got customers that are looking at all different types of trust anchors, secure elements by which to root their trust. It does not have to be a TPM, a Trusted Platform Module. So the idea is that by leveraging those and having that root of trust established, now I can build upon that. Now I can say, from that power applied root of trust, how do I get to secure boot? Well, I've got to take and validate measurements. Well, how do I get to those measurements? I start with my root of trust. And whether that's UFI or U-boot or something stronger, those are all things that are possible. So the idea is that somehow we've got to tie all these things together so that we have secure BIOS, so we have secure boot, first, second, and if there is a third stage bootloader. So we have secure applications, so we have secure executions and secure transport. All of those functions have to be cryptographically tied together. And the way to do that is through an orchestrated platform. All right, so I'm down to 7 minutes, which is 2 minutes ahead of schedule. Q&A. Anybody got any questions? Stump the chump. The question is, you want me to describe the relationship between the IT security, and trust mechanisms to the OT security and trust mechanisms?
Maybe how some customers that you know of have overcome some of the challenges of using existing lifecycle management, IT and OT?
I can tell you that in general, the OT world is standing up its own root sources. The attempts to tie into the IT world represent, from my experience, represent hurdles that nobody really wants to overcome. The IT guys don't want you using their CA. The OT guys don't want to have to use the ITCA because the ITCA is beholden on the IT guys to give them access to it, right? And they have the keys to the kingdom. If you're going to do a managed service associated with this, right, and you're going to distribute certificates to other components, you really don't want to be doing that beholden on some third party, unless, of course, you're going to do it through a third-party service. And that could be GlobalSign, that could be Digi, lots of different ways to accomplish this. At the end of the day, I think it comes back down to risk. You know, if you look at how 6443 or you look at how NIST 853 is constructed, it's all constructed on a risk model. What is your risk? Are you worried about the element being circumvented? In which case, what do you have to do to protect the element? If you have to protect the element at all costs because it's a near-peer nation state and it's existential to your customer's well-being, then you're going to throw the kitchen sink at it. You're going to stand up your own CA. You're going to put it in a secure process. You're going to wrap it in a secure border. Those are the kinds of things that you're going to do to establish supremacy of your certificate base. You're not going to go to some third party. Does that answer the question?
Yeah, are you seeing people they just cut a different certificate for their OT using the same, like let's say they have an HSM on the AT side instead of an ICA within their OT environment?
Yes. Right, so if you're talking about an organization having a root and having that root split between the IT and the OT side, yes, I have seen that.
You can use the same hardware, but you can just revoke separately.
Yes, absolutely. Now, again, somebody owns the keys to the kingdom there, right? So while you still own the keys to your OT kingdom, the IT guys can invalidate you in a heartbeat. So that's all I'm saying is that there are still problems associated with the trust linkage between the IT identity sources and the OT identity sources. They are not the same. They are not used at the same purpose. And more importantly, they do not share the same risk. Make sense? Did I answer the question? Cool. Others? 3 minutes and 52, 51, 50, 49.
How do they implement some of this? How do they ask for this type of management?
So again, coming back around to the risk equation, is an owner-operator can establish their own security model. It's non-trivial, but it's doable. You probably can't do it at the hardware root of trust level because you're not building the hardware root of trust. If you're inducing your manufacturer to have those capabilities and you want to leverage them, that's fine. But if to Emily, to your question, if you're asking about how does an organization come in cold and start to implement a program like this, the answer is you're not going to be able to get it embedded. You're going to have to do things like binaries. You're going to have to do things like rely on the file system. You're going to have to do things like implicitly trust some of the security mechanisms that you don't own, right? Whether that's IP chains and IP tables for access control, or whether that's signed kernel verification, or whether that's UEFI-based secure boot without an external trust anchor. These are all risk equations. What am I going to say? I'm going to say, here's the risk, here's the fix for that risk. Is it enough? Does it meet my requirements? Am I reducing the risk to an acceptable level? Then the answer is that's good enough. And again, there are binary agents out there. There are source agents that can be compiled into target environments. There are source agents that can be built upon for target environments. And all of those things are possible. What ultimately comes back down to is, what's your risk? What risk are you trying to solve for?